You'll subnet in like 6 or 7 other classes that you'll have here, so it's important that you get it in this one. We've already spent a couple weeks talking about the classes of addresses and the network and the host portion, and how to figure out how many addresses you can have and things like that. We've already started talking about it a little bit, but this is where we get into the actual math of making things work and trying to understand why they work. Now, we'll say this about subnetting. There's probably 6 or 7 different ways to do it. Sometimes you just have to find a way that makes sense to you. So I'm going to show you a couple of ways. You will hear some people talk about, oh, I have this chart I memorized. The chart stinks. Okay? Chart's not right all the time. What happens if you go to get into a test and you forget the chart? I'm always scared of things like that. I'm scared I'm going to freeze up and then it'll be over and I've lost this time and all this effort. So I'm going to teach you just math, because math is always the same. Math always works.
Unless it's Common Core.
Oh, well now we're not even getting into that. That doesn't make sense. But this math does. This is just normal math. So we're going to talk about subnetting, why we would want to do it, and then we're going to kind of introduce Class C subnetting. So when we talk about Class C subnetting, we're just worried about changing the last octet in the address. And that's it. Next week, the following week, we'll talk about the more complicated ones, but for right now, we're just going to talk about plain old Class C subnetting, the easiest one to pick up. So when we talked about networks in Chapter 3 and 3.5, we learned how we can define those with Class A, Class B, Class C. We talked about turning host bits on and off just a tiny bit and how that changes a subnet mask. When we went through the binary, we learned that when you turn bits on and off, it changes that number. So that only really works if you're defining one network. If you've got a big collection of computers that need addresses, that's great. That works. But as we know, if we have a whole bunch of computers all connected to the same router or to switches to the same router, we have a gigantic broadcast domain. Now, back when we ran Wireshark Packet Tracer, way like week 2 or 3, you saw how many packets could scroll through your screen in like a minute. And I mean, it was hundreds and hundreds and hundreds. So the more computers you add, the more of that activity you add, the slower your network's going to get, the more people are trying to talk, and it causes problems. So subnetting is one of the ways that we can fix that. So we can break these networks up into more manageable little networks, and we do that with subnetting. So in this example, this network is subnetted. The reason you can tell it's been subnetted is you can see this last group right here. The last octets are different. So this is the 0 subnet, this is the 64 subnet, this is the 96 subnet. So we've all kind of broken them up. We've put some routers in here. They don't broadcast out to other networks. So you can see that, oh, in the 32 network right here. They've made a subnet for that as well. So you can tell the last octet is different, and that's kind of what subnetting looks like for us. So if we need to create a subnet, there's a couple things we've got to do. The first thing we need to do, if we want to know what kind of subnet to use, we have to figure out how many host addresses we need. That's number one. That's the most important thing. If you configure a subnet and you don't have enough addresses for it, you're going to have to redo everything or make some kind of other way. You're going to have to fix things kind of in a funny way. So we talked about our network and our broadcast IDs. So the network ID is, we need one of those for every subnet, and we need one for each WAN connection, which is the one outside of the internet, right? We need to know how many hosts we need, and then we can start to create our subnets. So you may have a unique subnet mask that goes for the entire network. You can have an ID for each physical asset, each computer, each phone, each printer. And you might have a range of those for each subnet when you get done, and I'll show you how to do that, so don't worry about that. So the one for the LAN is the one that routes us outside of the internet. That's always the first usable address. We've talked about that a little bit when we talked in 3.5. You'll need an individual IP address and one for the router. And this is hierarchical. It gets more specific the further down you go, and we'll talk about how that works in just a second. So here are the default subnet masks for a Class A, B, and C network, just as a refresher. So where there is a 255, that's denoting the part that goes towards the network. Where there's a 0, that's denoting the part that goes to the node. Node and host are kind of interchangeable networking words. So you can see the pattern we have for our default subnet mask. Every time we go down a class, we add another 255, essentially, right? So the subnet mask, the whole point of it is to tell the computer, hey, this is the part that belongs to the network, and this is the part that belongs to the host. So when the computer sees something like this, and we'll talk about how you do this, when it sees something like this, that tells the computer, okay, the first 3 octets belong to the network, and these are the ones that belong to the individual computer. That's really the entire purpose of it. That's all it does. And we talked a little bit about those default subnet masks. Now, not all networks need to be subnetted. A lot of them are. For example, here on campus, we talked about with Class C, we get 2 to the 8th addresses, which is 254 usable.
Yeah.
With a B, we get 2 to the 16th, which is like, it's over 65,000. I don't remember the exact number. And then with an A, we have 2 to the 24th, and that's like really, really high.
Yeah.
I don't remember what it is. It's like, it's in the millions, isn't it?
Couple million.
It's millions. Because I'm not going to do that math right now because it's not important. But,
More than we need.
yeah, more than we need right this second. So, for example, to show you how we might subnet something in a real-world application. So, at TSTC, all of the cameras, the IP security cameras, are on a Class C network. The reason they're on a Class C network is because we're not going to have 254 of them, right? Things that are wired. The computers in all the classrooms, the ones in the internet cafe, the ones in the library, they're subnetted with a Class B because they wanted to separate the security cameras from everything else. Security cameras are generally statically assigned an IP address, so you can just go call them up and look at them. It's always the same. The B, they don't have to be statically assigned. In fact, I don't think they are in these classrooms. But all the wired computers, they gave Class B. And then all the wireless stuff, so all of your laptops and your cell phones and everything that come in on the wireless are the Class A. So in that way, they've subnetted TSTC in kind of a really easy way when you think about it, because it's just going to look and see what kind of device is trying to connect and then go from there. So there's an example of some real-world subnetting. That being said, pull up your command prompt. So that would be clicking on your start menu, typing CMD and hitting enter. When you get there, type in ipconfig and press enter.
Class A with a Class B subnet.
Yes. So you probably all start as a 10 dot something.
Mm-hmm.
I believe this room is on its own domain. I think that's why. So we're on a 10 dot something, but our subnet mask is a default subnet mask for a Class B. So if you want to look at something and tell if it's already been subnetted, that's how you would do it. It's got a Class A address, but the subnet mask is not the Class A. Yeah. What you got?
It says I got a Class C.
Yeah, I was like Class C.
Y'all have Class C? Okay.
You see in the VMware network?
Are you looking at the one that says local area connection? The VMware one will always be a Class C because you're never going to have 254 VMs on a computer because it wouldn't be able to handle it
No.
with that kind of
Yeah.
software. So, yeah.
C and D.
Yep. And
There you
then
go.
You got it. So I think this was my, this is probably my instructor computer in the office. Actually, no, it's my laptop. That was my laptop. That's why it's Class A, because it's a wireless device. So that's just an example of how you can tell if something has been subnetted. That's pretty cool. So, in a small office environment, we talked about network address translation and how the ISP only gives us one address, but every device on our network has to use it. So it kind of, the router does a little translation between a private IP address to the public one that the internet can see. We've talked about that a little bit. But if you're a business and maybe you're buying your internet connection per IP address for some reason, or maybe you buy a block of addresses, it would look like this. So what they would give you, and they would say, okay, this is your information, it would look like this, 192.168.10.28/28. The /28 is what we call a CIDR. CIDR stands for Classless Interdomain Routing. So, when we have our standard subnet mask for a Class A, it's got 8 bits turned on, and that's where the first 255 comes from, and everything else is a 0. The /28 tells us that this isn't a classy address. It's really called a classful address. I just think it's cute that way. But that tells you this is not a classful address, it's different. So really what the CIDR means, or what the slash notation means, is how many bits are turned on in the subnet mask. So, if I'm looking at something that's a /28, all that means is there are 28 bits turned on in the subnet mask. So that looks like 1, 2, 3, 4. There's the first octet.
255.255.240, I believe.
Okay. So I've got 28 bits turned on, so I've got 28 bits starting this way that are 1s. So I've got 8 here, 8 here, 8 here. How many bits have I used when I turn on all 3 octets?
24.
24. So 28 minus 24 is 4. So I have 4 turned on over here. And what's over here?
That's your,
Zeros. That's my host. Exactly. So when it gives me an address and it tells me /28, that's saying the address that you're getting is this, and this is what your subnet mask looks like. So if we were to add all that together, we would get 255.255.255. What? 128 plus 64 plus 32 plus 16 equals what?
240.
240. So when we went to go put in our IP information on our computer, we would put in that as the address, and we would put that in as the subnet mask. And we'll talk about that a little bit later. But when you turn on 28 bits, this is the subnet mask that you end up with. Make sense? Okay, so that being said, in a Class A, how many bits are turned on in a normal Class A address?
24.
How many network bits?
Oh, sorry. 8.
8. So what's the CIDR, the default CIDR of a Class A address? /8. How about a Class B, how many network bits are turned on? 16. So what's the CIDR?
16?
/16.
Yeah.
Right? Yeah. And a Class C, we've got 24 bits turned on the network side. So our slider is /24, right? See a pattern developing. Sliders are pretty easy. So if we took every possible slider value we could have, it would look a lot like this. So you can kind of start to see where the binary comes in, right? How many bits are turned on, you see the increments of what we were calculating a couple weeks ago, and what that slider value looks like. You're never going to see a slider 31 or 32, and we'll talk about one in a minute. So, you've got your 8-bit number and its value. When you add up the binary like we did here, that's what your subnet mask would end up being. Okay. One of the things that's really good to know when you subnet is the powers of 2. What's 2 to the 0?
1.
Okay, never mind, can't fill with that. Darn. So if you can remember 2 to the 1st, you can just double it every time. Some people, when they go into an exam, they want to write down the powers of 2 real quick. But just remember, like with 2 to the 2nd, you're just multiplying 2 by, or you're multiplying 2 twice. So 2 times 2 is 4. And then with 2 to the 3rd, it's 2 times 2 times 2 is 8. So especially up to 8, 2 to the 8th, you'll know it just by doing it. When you get into the higher level classes, you probably want to know the rest of them. But just a reminder of what powers of 2 means. Okay, so let's actually subnet. Now, this is the part where I tell you the math way to do it. There are other ways. I will show you another one after we get a problem finished. But here is essentially what we're looking at. So, if you want to see how many subnets does the subnet mask produce, and I'll show you an example of this, you would use, I always say 2 to the S. The letter you use is not important. What's important is this is the equation that gets you subnets. Subnets / networks, same thing. If you want to find the host per subnet, then you need 2 to the H minus 2, and that gives you hosts or nodes, however you want to call it, depending on how technical you want to be. And just a reminder that the broadcast address is the last available address in that subnet. We know we need the network address, which is the first available one. We need the broadcast, which is the last available one. And then everything in the middle is addresses we can actually assign and use. So, let's use this example. Put X's, because these, we're just working in this last octet, so none of these numbers really matter. Okay, so let's say I have 1 bit turned on. How can I find out how many subnets I have?
Well, you apply that 2 to the whatever.
2 to the what? 2 to the S is the bits turned on.
25th.
2 to the, this is the bits turned off.
Plus down 128,
Okay.
125 hosts.
So what's important here? Remember we harped on about the Class C addresses and the default subnet mask, and you did like 3 sheets of stuff on it and you're tired of it. The default for a Class C, the subnet ends right here, or the network bits end right here. So what we're doing to subnet, we'll go over this in more detail in a second, is we're borrowing a bit from the host side to get more subnets. So when we start plugging things into this equation, all that matters is this last octet. So if I want to find out, if I turn this bit on when it's not normally on, how many subnets does that give me? The equation I would use is 2 to the 1st for bits turned on, which is 2, right? So if I wanted to find out the valid hosts per subnet using this equation, what would that look like?
2 to the 7th minus 2.
2 to the 7th minus 2, precisely. That's like 27. All right, hugely. And what's that?
126.
125.
126.
26.
126. Y'all might have said that before, but there were lots of things happening. Excuse me. 126 hosts.
So it's 128 minus
128 minus 2, exactly. 2 to the 7th is 128. Minus the 2 we can't use, the network and the broadcast, you get 126 hosts. So if my dividing line was right there, by the way, what cider is that?
2. 128. You said what cider?
What cider?
Oh.
How many bits are turned all the way on? If it's a Class C, we know these are,
8.
right?
25.
25. 8 here, 8 here, 8 here, that's 24. One more turned on, it's 25. Don't worry, we'll do this till y'all hate it, so don't worry about that. Okay, so what if I turn one more on? Now my numbers are gonna change, right? My ones are my bits turned on, so that is 2 to the 2, right? 2 to the 2 bits turned on.
So we
4 subnets. Okay, now how many bits do I have turned off? 6. 2 to the 6 minus 2 is 62 hosts. The good thing about subnetting, that math always stays the same. Really all you have to figure out is where am I supposed to draw the line to make the delineation between the subnets, which is totally not hard. We'll go over that in a second. Now, what's the binary value of this number now?
192.
192. Right? So I have these other parts of this address. They're Class C. They don't really matter at this point. So yeah. Okay. So let's step through one. So here's an example. A lot of the problems that you'll see will be formatted in this way. It'll give you a network address. You can see that's a Class C address. It'll give you a subnet mask. You can see that that is not the default subnet mask for Class C, which means there's subnetting that needs to take place. So when we answer our 5 questions, I know part of this we just did. The 128 tells me there's 1 bit turned on here. The binary value of that field is 128, which tells me everything else is a 0. Okay. So how many subnets does that give me? Well, we said that with 1 bit turned on, it's 2 to the 1st, which is 2 subnets. And then we said that 2 to the 7th minus 2 is 126 IDs, host IDs. Okay. So now we do what we find the block size. With this, it's really easy. The block size just means this is how many addresses are going to fit in 1 block of subnet. So in this case, wherever this last 1 is the block size. Whatever the binary value of the place where the last 1 is the block size. So when we look at this, we'll say, okay, well that's what we're going to increment by. It's called different things in increment value or block size, whatever, a magic number, whatever. It doesn't matter. But it's really all the work is getting to find that. Once you find that, the rest of the subnetting is actually really easy. So if I want to subnet an address that has 1 extra bit turned on it, it's a Class C. my first subnet is going to be 0 because the first subnet is always 0. Always. My increment is going to determine what the second subnet is. What's 0 plus 128? 128, so my second subnet is 128. And I know that I have 2 subnets from up here. So that's all the subnets I have. 2. That's it. Now, we know that the broadcast address is the last usable address in that range. So it's going to be 1 less than the network address on the next subnet. So our broadcast in this case is 127. What's my broadcast at the second subnet? 255. Why? It's the last available address. If I add 128 to this, I get 256, which is not valid. And I already said I only have 2 subnets, right? So what are the actual valid assignable addresses in this first subnet? 1, 126. Hey, wait, that sounds familiar. Didn't I say it had 126 usable hosts in each subnet? Right? How about this one? 129, 2, 254. Yeah, we just subnet it. I'm gonna go home now, right? It's not that bad, right? Just math. Don't actually try to leave. So, in a Class C address where 1 bit's turned on, what CIDR is this again?
25.
/25. So in a /25 network, that's what it always looks like. That's the good thing about subnetting. It's always the same. The math is always the same. In a /25 network, you will always have 2 subnets and 126 usable hosts. Because the numbers will always look like that. When this starts changing is when we start changing our bits up here. Does that make sense? So here's another one. I know, that's exactly the one we just did. So when you would write it out, this is the way I like to present the information because it makes sense to me. Later on, I'll ask you questions about the subnet. I'll say the address 192.168.10.4 belongs to which subnet? Well, the .4 would fall in the range, the usable range of the 0 subnet. So your answer would be 0 subnet. So listing things like that makes it easier for me to understand. I can tell you that of all the ways I've heard of subnetting and the ways I've seen people teach it, to me this is by far the easiest. So there's an example of our /25. So I've got 2 subnets, I've got 126 hosts in each subnet. The broadcast is the last address, the network address is the first one. Network address, subnet address, same thing. And I've got my valid range of hosts that I can come up with. So, why on earth would anyone ever want to do this?
You've got fewer hosts, but you need more than 1.
Okay. In a lot of businesses, they'll normally separate things by department.
Yeah.
Like everything is separated by department because generally the people in payroll need about the same things. The people in sales need about the same things. They're going to be on the computer about the same amount of time because they have the same kind of jobs.
Social security.
And for security reasons, which we'll talk about, we will talk about security reasons in here. So if you were to actually put this in practice and you said, okay, well I want the salespeople, I have exactly 126 hosts or less of salespeople and 126 or less of accounting people, and this is the address that the ISP gave me, so this is what I have to work with. So I'm gonna subnet this so that these people's traffic can't cross, essentially. So it's a separation on a network. The broadcasts that happen in the sales don't happen in accounting because they're separate networks. That's the reason you would actually do this. So in this case, I've got two subnets. The 0 subnet belongs to sales and the 128 subnet belongs to accounting. So we have all of our addresses on every computer being assigned all the way down to the last one that's available. That's why you would actually do this. It's really, really common. So, they're created to keep your broadcasts at a normal rate. They're also there for security reasons. So sales and accounting, let's assume accounting has payroll in it. The salespeople don't need to know anything that happens for other people's paychecks, right? All that information is stored on some server somewhere else, or it's on a computer in the accounting department. The people in sales don't need to see that. So when you separate them with different subnet addresses, it means they can't crosstalk unless you absolutely make it that they can. You have to set that up as the administrator. So it has to kind of go through you as the administrator before it actually happens. So if you had tens of thousands of computers trying to talk and pass data over a network with 254 hosts or something, it could kind of slow the network down significantly. Actually, you couldn't have 10,000, but you know what I mean. The other reason you would do this is you're an internet service provider. So when you think about it, the internet service provider gets handed these amount of addresses. And they have to give those out to all their customers. Now generally, as a small business or a home, you just get one address and that's not a big deal. But really your address is subnetted down from the block of addresses that the ISP got to give out to people. So they subnet all the time. People like Longview Cable and Fidelity and Network Communications, they might be able to give you a block of addresses. Because you've got more than 254 computers, right? Okay. So if we turn another bit on as we did earlier, so now we're going to turn on another one, which makes our CIDR 26. 26 bits turned on. How many subnets should I have? 4. The 2 is 4. How many hosts should I have? 2 to the 6?
62.
62. Okay. So let's put actual numbers into this. Well, we can do that. Let's make it look like real addresses that we would use if we were actually going to subnet something. So the address they give us was 192.168.10.0, and we're supposed to subnet that with that subnet mask. So when we did that, and this is formatted a little differently, but I'm going to run it here. What's my increment value? 64. The place where the last one is, whatever the binary value of that field is my increment value. So I should have 4 subnets. Okay. What's my first subnet? 0, always. What's my next one? 64. 0 plus 64, 64. But this one?
128.
128. 64 plus 64 is 128. What about this one? 192. What's the next one? More than 255, right? So it doesn't matter. We already said we had 4 subnets. Right. So what is my broadcast for the first subnet?
63.
63. How about for this one?
127.
127. This one? 191. This one?
255.
255. So that means my usable range is gonna lie between those. So really, you could write out this whole 1.192.168.10.62 and say that's the usable range. But you kind of start to see the pattern developing here, right? So what's important is to figure out that increment. Whatever form they give you the question in, and we'll go through every one you'll ever see. But whatever form they give you, as long as you can find that number, you can figure out everything else pretty easy. It's just adding, right? Okay. So if we turned another bit on, turned another bit on. How many subnets would I have? 8. 2 to the third is 8 subnets. How many hosts would I have?
32. 27.
No.
30.
30. 2 to the fifth is 32. Minus 2 is 30, right? Okay. What's my cider?
27.
27. What value is that?
32.
32.
So, wait.
Yeah.
To get the host, I have to do 2 to the power of how many zeros there is?
Absolutely. Minus 2. Exactly.
What's your
No one's crying yet. That's a good sign. Okay. So once I find out my increment, I do everything else.
And how'd you say you got 27?
There's 24 bits turned on here, right? 8, 16, 24, 25, 26, 27. I have more subnets. What's my first one?
0.
0. Second.
32.
32. Third.
64.
Right. I mean, the answers are right there, but you know. So, just like I thought I would, 1, 2, 3, 4, 5, 6, 7, 8 subnets. So you can see where that's going, right? So we've got our broadcast and our first and our valid would look just like that. Okay, so let's do one with no assistance. So I'm turning on another bit. And again, I'm turning on another bit because it's 128 plus 64 plus 32 plus 16 equals 240.
Be 2 to the 4 subnet,
Uh-huh,
be 16.
uh-huh.
It'd be 2 to the 4 minus 2, which would be, 14.
Yep. Don't worry, we're not gonna draw out all 16. It's not get crazy. First one's always 0. What's my second one?
16,
16, why?
because that's the increment.
That's the increment right there where that one stops. $80, 96, 1. Math is hard. 112? Is that right? Is that what 96 plus 16 is? You can calculate.
Yeah, it'd be 1.
Okay. And then 128. And then 154.
144.
Oh, they're dispute. 128 plus 16.
144.
144. Okay. All right. 144 plus 16.
170.
Yeah.
16.
160. Okay. 176. That's a lot of subnets. 192. 208. 4. 8, yeah. 240. And then 256, which means we're out of our range, right? So I should have 16 subnets. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Right? So then from that, I can be able to tell, for example, one less than that is 15. Right. And my cider is 28. Right? Okay. So if we add one more bit, then our cider becomes a /29. What does our increment value become?
8.
8. Right? I'm not going to draw that out. I just want you to understand. Hopefully you're starting to see a pattern emerge here. That's what I'm going for.
6 hosts.
Okay. So in this case, we would have a lot of subnets, right? We would have a lot of subnets with a very small amount of hosts in each one, right? So 2 to the 5th is
32.
32. 2 to the 3rd minus 2, 6. So now I have a whole bunch more subnets with a very small amount of addresses in them, right? So the last one you can have is a /30. If you have a /30, now I've got 64 subnets with 2 hosts in each one, which is fairly impractical, huh? That's a crazy small subnet. So if you've got your book with you, flip over to page 156. So a lot of the things that we just went over are in this what do we know section. So once y'all take note of that, when you have a /25, your subnets and your host, 26, a 27, you'll tell me what pattern is emerging there. Okay. Let's think about it in relation to the number of subnets and the number of hosts.
Everything is halving each time, or doubling. It's doubling on one side, it's halving.
It's doubling on one side, and it's halving on the other side.
The subnets, if you take the bits, it's backwards. Like, if the first bit's turned on, you have 2. So like the 8th place on the bits is 2.
Mhm.
So if you only have 1 turned on, you have 2 subnets. It's
Okay.
like if you wrote the bit places, the
Mhm.
bit values backwards, that's how many subnets you have. So that's 2 subnets. 2, 4, 8, 16, 32.
Okay. Yeah. You're getting there. So we notice a pattern here. What's 2 times 128?
256.
256. That just happens to be the total amount of addresses I have in that. From 0 to 255. I have that many addresses. We talked about this one. I had 4 subnets. I had 64 hosts. 4 times 64, 255, 256. So you see a pattern kind of emerging here. As my subnets increase, my hosts decrease. The halving and the doubling.
What's half minus 2?
Half minus 2. I'm not taking into account usable addresses here. I'm
No.
saying the total number of addresses. Only because it kind of helps reinforce the point that you've used up every address for whatever configuration you pick. So like in this one, I had 8 subnets, and I had 32 hosts. So you see the pattern that develops as we go down the list. So that is the relationship between subnets and hosts. My subnets increase and double while my hosts decrease and halve. So you see why earlier I said the first thing you do is determine how many hosts you need, right? If you need 64 hosts in each subnet, that's where your increment's going to be. If you need 128 hosts, that's where it's going to be. That's how you determine where to subnet. Now, another way people teach subnetting, this one's quick. That powers of 2 thing, we really get into that here. So one thing that they'll say is count your subnets from left to right, count your hosts from right to left. I don't think quite that fast, and I like to double check. This is normally what I use to check myself. So for example, let's take this last octet again. The things that we just wrote down we're about to prove, right? 2 subnets here, 4 here, 8 here. You see we're counting and we're doubling the number every time. And we do the same this way with hosts. We have 2 here, 4 here, 8 here, and so on. So one thing people will do is they'll go ahead and write this out. Let's do one we haven't really done yet. And they'll say, okay, if I want to count my subnets, 2, 4, 8, 16, 32 subnets. If I want to count my hosts, going this way, 2, 4, 8. Make sense? You're doing this essentially. You're doing the same thing, but it's a nice little check to make sure that you got something right. Because the list we were doing where we were going through the subnets, if you mess up one of those numbers, it's going to throw everything else off. So that's one of the reasons I like to talk about these. Because you have these to check with. You can also just account to double check that you're picking the right place to draw the line. So once we draw this line here, and we get this cider, which is 5, 6, 7, 8, 9, 29. And we get this increment value, which is 16, right? Yeah. That tells us everything, that's great. But if we're listing things out and we get off track, everything else is going to get off track and it's going to be wrong. Now, what your assignment is for today. Uh-oh. And you can look, there in the book, there's way more examples than what we went over today. Let's talk briefly about why you would never have a /31 or /32. You may see it like for the purposes of doing an exercise, but in a practical, real-world application, they would never use that. So a slash, wow, I'm killing my marker. That makes me feel good. And a /31. That means all but the last bit would be turned on, right? Because we've got 32 bits. So when we do these equations up here, are 2 to the s. 2 to the 7th is what? 128. What about our host? 2 to the 1st minus 2.
0 hosts.
0 hosts. So there's no point in subnetting to that level because you don't have anything to work with, which is the entire point of subnetting, trying to come up with hosts to work with, right? So the same thing for a /32. At this point, you're not even subnetting, really, because you don't have anything to work with. Now you've got 2 to the 0 minus 2 hosts, which is still 0. Actually, it's -2. So that doesn't work, right? I know it's -1, right? So you won't see anybody use a 31 or a 32. Okay.
Does that not become a network broadcast?
It does. Well, it becomes the overall broadcast for all of the.
I've seen
Yeah.
public addresses with all 255s. I've seen those when you do an IP config on public addresses. It's very, very strange. It's like, what?
On a
You know.
public address.
Yeah,
Yeah.
I've seen it.
No, that makes sense. That makes sense. Okay, so in the book, in that what do we know, in the solder notation, there are a lot of what we've gone over today just to reinforce, help a little bit. Your actual assignment
Oh, I understand. If it's
is
all-
on,
Sorry, if it's all 255s on the broadcast on the public, that means you're only given one IP address as your network address.
yep,
Yeah,
That's
that
it.
makes sense. Sorry.
so you don't need a subnet mask. Because your only entrance outside is to the internet,
Well, you can't subnet the IP address that they give you.
the one that they give you.
That's right.
Yeah. Okay, so on page 171 of your book, there's Written Lab 4.1. This will probably have to be something you'll actually physically write and turn in. I've had people do it on the computer, but it gets kind of messy. It's up to you. So we want you to write the subnet, the broadcast address, and the host range for the first 6 questions. We did those in class today, and I will be posting the lecture up on the Moodle if y'all want to go back and look at something again. So the way that makes sense to me is the little chart where you have the subnet first and the broadcast last and the range in the middle. Different things make sense to different people as long as I can figure it out or I can ask you about it and you can recreate it or tell me why. It doesn't matter to me. Whatever way makes the most sense to y'all. Then 7, 8, 9, and 10 on page 172, it's part of the written lab, are going to ask you some general questions that you might have to do a little bit of figuring to figure out. So it's just saying things like, if you had a CIDR of 29, how many hosts would you have? So you can use the equation that we talked about earlier, right? So if I have cider of 29, so that'd be 25, 26, 27, 20, 29, which means it would be there. That's where my last one is. How many hosts do I have? Well, I know these are going to be zeros and these are going to be ones.
32.
No. 2 to the third. 8 hosts, 6 of which are usable, right?
Right.
So you can use those equations and stuff. If you have a question, raise your hand and ask me. But that is your assignment for today. That written lab 4.1.